Next is what is mass of nucleus. So the nucleus is consisted of protons and neutrons. So the mass of the nucleus should be total mass of the protons and neutrons present in it, that is total mass of nucleus. So if there are n number of neutrons and z number of protons, then mass of nucleus should be n into mn plus z into mp, where mn is the mass of one neutron. So total mass of n neutron is n into mn plus mp is mass of one proton. So total mass of z number of protons is z into mp. So total mass of nucleus should be n into mn plus z into mp. But it is observed that the mass of the stable nucleus is less than this above value. That is, mass of a stable nucleus is less than what it should be if we consider the total mass of the all the nucleons present in the nucleus. So some amount of mass has disappeared. So what has happened to that mass? So the amount of mass which has disappeared is called mass defect. Okay. So the mass of a stable nucleus is always found to be less than the sum of masses of constituent nucleus. And notice that this case is applicable only for a stable nucleus, not for an unstable nucleus. So the mass of a stable nucleus is always found to be less than the sum of the masses of the constituent nucleus, that is the total number of total mass of the total number of protons and neutrons. The difference between the sum of the masses of constituent nucleons and the measured mass of the nucleus is called mass defect. So let us consider a nuclide with the simple XZA. So there are Z number of protons and A minus Z number of neutrons. If mass of one proton is mp and mass of one neutron is mn, then total mass of the nucleons is Z into mp plus A minus Z into mn. But as we know that for a stable nucleus, measured mass or the actual mass, original mass of the nucleus is somewhat different from the total mass of nucleons, and let it be M nucleus, capital M nucleus. So according to the definition, the mass defect denoted by delta M is the difference between the total mass of the nucleons and the measured mass or at the actual mass of the nucleus. So formula of mass defect is delta M is the total mass of nucleons minus actual or original or measured mass of the nucleus. Now mass defect, sometimes another definition of mass defect is also given, which is you consider the atom where there is a in the nucleus there are protons, neutrons and electrons. You consider mass of all these elementary particles and then you measure the actual original mass of this atom. Again you will find that there is some difference between these two values. That is also sometimes called as mass defect. So sometimes it is also defined as the difference between the actual mass of an atom and the sum of the masses of its constituents, that is protons, neutrons and electrons. So for example, mass of an helium atom is, actual mass is this 4.00260 AMU, that is atomic mass unit. But the total mass of its components, that is there are 2 neutrons as we know, 2 protons and 2 electrons, is 4.03298 AMU. So difference between, as you can see that clearly that these two numbers are not equal, they are different. So the difference between the values of the masses is called mass defect. Okay, so here we have the diagram. We are showing this thing in as a diagram. So as per this diagram you can see that this is the helium atom with 2 protons and 2 neutrons in the nucleus and 2 electrons revolving around the nucleus, and the actual mass of the helium atom is this. But if we consider the mass of its component elementary particles separately, and if we add them, mass of 2 protons, 2 neutrons and 2 electrons separately and add them, we will get this value. So what will be the mass defect delta M? It is this value minus this value, which is this 0.03038 AMU. Next is packing fraction. So what is packing fraction? The packing fraction denoted by symbol F is defined as the mass defect per nucleon in the nucleus. So if mass defect of an atom is delta M and mass number is capital A, then the packing fraction is F delta M divided by A. So in this example, here mass defect is this much, and what is mass number? Mass number is 4. 2 protons, 2 neutron, 2 plus 2, 4. So packing fraction in this case will be this 0.03038 AMU divided by 4. So that will be packing fraction for helium atom.